Hello, in this discussion we're going to be using double angle formulas to establish identities, among other things. Okay, let's begin. So we're going to develop a formula for the tangent of 2 theta. We haven't done that one yet. We've done the sine of 2 theta, and we've done the cosine of 2 theta, but we've not have done the tangent of 2 theta. And we're going to do it in terms of tangent of theta. And the second thing we're going to do here is develop a formula for the sine of 3 theta in terms of sine of theta and cosine of theta. Now B here, sine of 3 theta, it's worth doing, but it's not worth memorizing. Okay, every time I need the sine of 3 theta, I just redo what I'm about ready to show you in here in part B, because the memorization of it takes up too much of your brain to figure that one out all the time. So I would just develop it as I need it. Alrighty, so develop a formula for the tangent of 2 theta. Let's look at this. The sum formula tangent of alpha plus beta, where alpha equals beta and theta. Now, if you recall, tangent of alpha plus beta is the tangent of alpha plus the tangent of beta over 1 minus the tangent of alpha, tangent of beta. That's the summation formula for the tangent of alpha plus beta. Now, in this case, though, tangent of 2 theta is the same thing as the tangent of theta plus theta. So in this case, alpha is theta and beta is theta. So we just take both of the alphas and betas and replace them with thetas. But when you do that, it's tangent of theta plus tangent of theta over 1 minus the tangent of theta times the tangent of theta, which gives you the identity. So the tangent of 2 theta is 2 tangent of theta, because tangent of theta plus tangent of theta on top is 2 tangent of theta. And 1 minus the tangent of theta times tangent of theta is tangent squared of theta on the bottom. So that's the double angle formula for the tangent. Okay, now let's look at part B. To get a formula for the tangent, a sine of 3 theta, we write 3 theta as a sine of theta plus cosine of theta, plus theta. So basically 2 theta plus theta will be 3 theta. And then you'll use the addition formula for that one. So it'll be the sine of 2 theta times the cosine of theta plus the cosine of 2 theta times the sine of theta. Now, we're not done, because it said in the instructions to write it in terms of sine of theta and cosine of theta. No 2 thetas are going to be allowed. So then you take the sine of 2 theta and use the double angle formula for that one, and find the cosine of 2 theta on the right and do the double angle formula for that one. And then there it is. So you get sine of 2 theta, which is 2 sine of theta, cosine of theta, times the cosine of theta that's standing. And then they chose to use cosine squared minus sine squared of theta. That's your first one of your double angle formulas for cosine. Remember, it equals 2 other items. So you could pick either one of them, it doesn't matter. And then multiply that times the sine of theta, distribute the cosine on the left and distribute the sine on the right, and you end up with the formula. So it'll be 2 sine of theta cosine squared times sine of theta cosine squared minus the sine cubed of theta. So there were some terms that you were able to collect. But if you notice, they're all sine of thetas and they're all cosine of thetas. Sure, some of them are squared and you got the sine cubed on the end, but it's still sine of theta. So no double angles or triple angles are in that one. So what was the trick here? You rewrite 3 theta as a sum of 2 theta plus theta using the addition formula, and then that gives you an expression that has double angles in it, and then use the double angle formula to knock those down to single thetas. And that's as simple as that. So it takes a little bit of algebra, but as you can tell, that's something you would not want to memorize. Sine of 3 theta is 2 sine of theta, cosine squared of theta plus sine of theta, cosine squared of theta, minus the sine cubed of theta. So you can memorize it if you want, but you use it very seldomly. And so this is just one good thing to develop. Alrighty? Alright. So let's look at another example here. So cosine of 2 theta is 1 minus 2 sine squared of theta. Alrighty? Now we know that that's a double angle formula. Now let's look at that a little closer. What if we try to solve that equation for sine squared? So that means the 1's got to go to the other side and divide by -2, and you can rewrite it to look like that. So sine squared of theta equals 1 minus the cosine of 2 theta divided by 2. So it's the same formula. It is the double angle formula for cosine. It's one of the formulas. But when I rewrite it, it's no longer called a double angle formula. It's called a power reducing formula. So what that basically means, if you want to evaluate a sine squared of an angle, and you don't want to square anything, then all you got to do is take cosine of twice that angle, subtract it from 1, and divide it by 2. So, and you're like, well, why would I want to do that? Well, maybe I don't know how to evaluate a sine squared function on my calculator. Or maybe something a little bit more ominous that comes later on. What I mean by that is something in calculus comes up and it's called derivatives, and you're going to try to apply something to it. And taking the derivative or whatever to a sine squared function, maybe it's a little too complicated, and sometimes it is. But it would be easier to take that derivative or whatever it is to the function that's on the right. So being able to rewrite it from a power sine squared to a regular function like cosine of 2 theta becomes a lot easier in some cases. So that's called the power reducing formula. So even if you don't truly understand that right now, you will when you get into calc. Because when you start taking derivatives, you are not going to necessarily want to take the derivative of what's on the left. You prefer to take the derivative of what's on the right, sometimes. Or even the integral, sometimes. Okay? Now, so cut out cosine, remember 2 theta is also equals 2 cosine squared of theta minus 1. So what if in this case we're going to isolate the cosine squared? That's what it becomes. So it's very similar to the one above it, except it's plus. So cosine squared of theta equals 1 plus the cosine of 2 theta divided by 2. Guess what this one's called? Yep, it's the power reducing formula for cosine. So we have a power reducing formula for sine, and we have a power reducing formula for cosine. But the reasoning is the same as the reasoning above. Sometimes you might want to integrate the cosine squared. Easier to integrate what's on the right. Okay? Now, well, we got a power reducing formula for sine, and we got a power reducing formula for cosine. How about tangent? Well, tangent squared is equals to sine squared over cosine squared. And then sine squared, we know that one by the top one. We know cosine squared by the middle one. And then we invert and multiply. The 2's cancel. And it gives us 1 minus the cosine of 2 theta over 1 plus the cosine of 2 theta. So these are the power reducing formulas for the sine, the cosine, and the tangent. Okay? And you're like, well, do I have a power reducing formulas for the other ones? Think about it, what they would be. What do you think cosecant squared of theta would be equal to if you want to reduce the power? Because you know sine and cosecant are reciprocals. So cosecant squared of theta would be the reciprocal of what's you see on the right. Alrighty? So you do have the other ones as well, although I don't have them stated here necessarily. Okay? So let's look at an example here. We're going to write an equivalent expression for the cosine to the 4th of theta that does not include any powers of sine or cosine greater than 1. So in other words, we don't want any cube cosines. We don't want any squared cosines. We want all powers to be 1 at the most. Okay? So let's look at this. All righty? So we have cosine to the 4th. We know is cosine squared of theta squared. Now, you remember cosine squared power reducing is 1 plus the cosine of 2 theta divided by 2. Because I replaced cosine squared of theta with 1 plus cosine of 2 theta divided by 2. Now, these power reducing formulas that was on the previous slide, you need to have those on an index card. So you might want to go back to there and pause that and relook at that again and write those on an index card like you do with all your formulas that you've done so far. All right? All right. So then you get 1/4 times 1 plus cosine of 2 theta plus cosine squared of 2 theta. So you're like, how do you get that? Well, you just have to FOIL it out, and then a 1/4 comes out. All right? So you could actually square the 2 on the bottom and factor it out immediately and never deal with it. And then just write 1 plus cosine of 2 theta times 1 plus cosine of 2 theta, And what that gives you is what's in the parentheses, or I should say, yeah, it's the bracket on the right. So, but you're like, well, okay, I'm done. No, you're not done, because what do you see? Well, 1/4, 1, 2, cosine 2 theta, all that's good. But look at there, it's like cosine squared of 2 theta again. So I need to get that reduced down to a certain power as well. So if you get that cosine squared of 2 theta, that is going to be, well, they distributed 1/4 is what they did first. And then you take the cosine squared of 2 theta, all right? And then you go, that's 1 plus the cosine of 2 times 2 theta divided by 2. All right? Now that's going to end up being 4 theta. You double that theta. So the 1/4 stands, the 1/2 cosine of 2 theta stands, and then you take that 2 out and be a 1/8 times 1 plus the cosine of 4 theta. And you're like, well, yeah, but by reducing the powers, it's making theta double every time. So now you're already up to a 4 theta. Alrighty? Well, that is neither here nor there. That's fine. I mean, you can double, quadruple angle here like you have here. And if you're going to integrate it, you would much rather integrate it with it looking like this than you would with the original cosine to the 4th of theta. Alrighty? So that's the purpose of it. Now, you're like, well, what's integrate? Well, that's going to be a calculus thing that you'll learn. But I'm trying to let you guys see that a lot of the things you do in this course, you don't see why you're doing them until you get to the next class. So you got to be patient if you want to know the why. Alrighty? So right now you just need to learn how to do it. And then when your calc teacher shows you, okay, let's integrate this function cosine to the 4th of theta, and then you have to rewrite it this way, then you'll know why you're learning it in here, because you don't want to learn it in the calculus field the very first time, because then you lose sight of the term integration to begin with. So this is kind of like the prelim. This was why it's called pre-calculus. You learn how to do some of the processes first to do some of the big stuff later. All right? Now you distribute the 1/8, and it turns out to be 3/8 plus 1/2 cosine of 2 theta plus 1/8 cosine of 4 theta. Like I said, yeah, there is a lot of double angles and quadruple angles there, but there are no powers on any trig function, namely cosine here, other than one. Cosine of 2 theta, cosine of 4 theta. No squares, no 4th powers. And for like I said, for right now, you look at that and you're like, well, that looks messier than what I started with, cosine of 4 theta, cosine to the 4th of theta. So what your answer is looks worse than what you started with. That's true. But there's some techniques that you're going to have to learn later on that this longer expansion is going to serve you well as better than what you have to begin with. So just kind of keep that in mind. All right, let's look at another example. Okay, this time we're going to solve an equation, cosine of 2 theta times the cosine of theta minus the sine of 2 theta times the sine of theta equals 1/2. Now, this is one of my addition formulas for cosine. So remember, cosine of alpha plus beta is cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. So cosine of 2 alpha, cosine of alpha, minus the sine of 2 alpha, sine of theta, thetas, all these are thetas, is equals to the cosine of 2 theta plus theta. So, and that's cosine of 3 theta. So if cosine of 3 theta equals 1/2, well, you know when the cosine is 1/2. Where is that going to be? At 1/2. When is cosine equal to 1/2? Go back to your chart if it's necessary. By now you should have this memorized. But it's at pi over 3 and 5 pi over 3. Because that's where it's positive. So it's going to be, I think we duplicated that there. I think now it's the same row there. So that means it's going to be at pi over 3 plus, and then, they made a mistake here. Do you see it? Well, let's look at the first one first. Cosine of 3 theta equals pi over 3 plus 2 pi k. Now, if you want to solve for theta in that case, you would need to divide by 3, and that's going to be pi over 9 plus 2 pi k over 3. So the first one's good. I'm just having a little bit of trouble with their second one. 3 theta does not equal 2 pi over 3 because cosine equals 1/2 in the fourth quadrant. Remember, cosine's not negative. I mean, it's not positive in the second quadrant. It's negative in the second quadrant. So that 2 pi over 3 plus 2 pi, it should be 5 pi over 3 plus 2 pi k, or 2k pi, whichever. So you need to pause this video. You need to take that 2 pi over 3 off, and you need to then rewrite it to 5 pi over 3 instead of 2 pi over 3. And then your final answer would be theta equals 5 pi over 9, not 2 pi over 9, plus 2 pi k over 3. Now what that is basically doing, though, is it's giving you all the answers. So pi over 9 and 5 pi over 9 are answers in the first, between 0 and pi, 0 to 180 degrees. But there are others, all right? So you just need to be careful with that. But again, pause the video. Again, I would occasionally write a lot of these equations down. Pause them, write it down what I wrote down, re-listen to them sometimes, and then this is the one you really need to write down because there is a mistake on this slide. Instead of 2 pi over 3, it should be 5 pi over 3. So there is a mistake there. All righty? All right, let's move on. Alrighty, so an object is propelled upward at an angle of theta to the horizontal with an initial velocity of v sub 0 feet per second. See the diagram below here. Okay, if air resistance is ignored, the range r, which is the horizontal distance that the object travels, is given by the formula r equals 1/16 times v sub 0 was that squared? Yep, squared times the sine of 2 theta. All right. Oh, well, that's what we're going to have. We want to show that 1 over 32. So it's going to be 1/16 times v sub 0 sine of theta times the cosine of theta. And we want to show that that's going to be 1 over 32 v sub 0 squared times the sine of 2 theta. And we also want to find the angle theta that which makes r a maximum. All righty. All right, let's do the A first. So if you remember, now r theta is 1/16 v sub 0 squared times the sine of theta times the cosine of theta. But that sine of theta times the cosine, if you put a 2 in and divide it by 2 immediately, you do not change the problem. So you got 2 divided by 2, and you're like, well, why would you want to do that? Because if you remember, 2 times the sine of theta times the cosine of theta is my double angle formula for sine. So if I take the 2 sine of theta cosine of theta that comes out of that and change it to sine of 2 theta, and then bring the 2 that's down on the bottom out to with a 1/16, and so you'll have 1/2 times 1/16, which is 1/32. So you take the 2 on top and bottom, and it doesn't change it, but the 2 on top is going to allow you to use a double angle formula, and then having that 2 on the bottom is going to make the 1/16 that's out front a 1 over 32. Okay? Now you're like, well, that's good, but why would I need to know something like that? It's for the answer to part B. What angle theta for which r is a maximum? Okay? So what does the theta have to be in order for it to be a maximum? Well, the only way this is a maximum, okay, the only way this is a maximum is if the sine of 2 theta is 1. Because the initial velocity squared is already going to be set. And so sine of 2 theta, if sine is 2 theta falls between -1 and +1. So in this case, between 0 and, basically between 0 and 1. Now, which is the biggest of all those numbers? Well, you got 0.1, 0.2, 0.3. 1's the biggest. So sine squared of 2 theta is going to be the biggest when it's 1. Well, sine is 1 at pi over 2. Right? So sine is the biggest at pi over, Sine of pi over 2 is 1 there. So, since the largest value of the sine function is 1, according when the argument 2 theta is 90 degrees, it follows that for the maximum r, we must have 2 theta to be 90 degrees. Because remember, sine of 90 degrees is 1. That's when it's going to get the biggest. So therefore, your 2 theta has to be 90 degrees, which makes theta to be 45 degrees. So basically, your angle has to be 45 degrees in order for this projectile to go the furthest. Okay? Anything lower than 45 degrees, it's not going to give you a maximum distance. You'll hit the ground. If you bring it above 45 degrees, you'll get more height on the projectile, but you won't go as far as a distance. So anybody that's ever threw a football kind of knows that. If you throw a football straight out in front of you, you don't get much distance. But if you loft it at a 45-degree angle, you get more distance out of that. Same principle is being applied here. Okay? So anyways, that's kind of a hands-on problem that you would want to, you see that why you would want to go from single angles to a double angle, like in part A here. Okay? So, alrighty. That concludes this discussion. If you have any questions on it, you let me know, and you have a good day.